Okay, chapter 11, last chapter. So we start with polygons. What's going to happen is we're going to break down any polygon into triangles because we know a lot of stuff about triangles. And then we're going to be able to apply it to any polygon. Okay? So polygons. We know that we name a polygon by its number of sides, and then that turns out to be the same number of angles. Okay? So triangle means 3 sides, quadrilateral means 4, pentagon means 5, and hexagon means 6, for example. So that's something we've done before, okay? So the sum of the measures of the interior angles also depends on the number of sides, okay? So we know that the sum of a triangle, of the angles of a triangle, is 180. Then back in chapter 6, we looked at a quadrilateral, and we said a quadrilateral had 4 sides, right? So here's 1, 2, 3, and 4, okay? And we took that quadrilateral and we divided it into 2 triangles to then say that the sum of the angles there of a quad was 360. Okay? Well, we can do the same thing to find the measure of interior angles of any convex polygon with n sides, called an n-gon. Okay? So if you go through the activity on page 661, you have your triangle, you have your quadrilateral. Pentagon is 5 sides, so 1, 2, 3, 4, 5. If I take one vertex and draw in all the diagonals, here would be 1, 2. Okay, well, how many triangles is that? That's 3 triangles. Each one adds up to 180. Okay, so 3 triangles. Then that means that it's 3 times 180. Or for a pentagon, that ends up being 540 degrees. Okay, well, if I take a hexagon, so that's 6 sides, right? So 1, 2, 3, 4, 5, and 6. Okay, draw on my diagonals. Here I get 1 diagonal, 2 diagonal, 3 diagonals, and I end up having how many triangles? Well, there's 4. So it ends up being 4 times 180, which ends up being 720 for the sum of those angles. Okay, if you continue this pattern, it ends up getting you your very first theorem for chapter 11, and it's just theorem 11.1, which tells us this polygon interior angles. Okay, and what it says is that the sum of the measures of the interior angles of a convex n-gon, so an n-sided polygon, is going to be n minus 2, because if we look here, there are 5 sides, 3 triangles, 6 sides, 4 triangles. So the number of sides minus 2 gives you the number of triangles. So it's going to be number of sides minus 2 times 180. Okay? And then the the corollary to that, so an addition, tells us that if it's a regular n-sided polygon, right? Regular means all angles are the same. Okay, then the measure of each angle is going to be the total divided by how many angles there are. So 1 over n times n minus 2 times 180. Or you could rewrite that as n minus 2 times 180 divided by n. And that works for a regular polygon. Okay, because the sum of the polygon is n minus 2 times 180, But then if it's regular, all angles are the same. So you take the sum and divide by the number of sides or the number of angles, and you get what one angle is equal to. Okay? So that's our first two theorems. And then, first theorem and its corollary. The second theorem now, so that refers to the interior angles of a polygon, okay? But if I want to talk about the exterior angles, we can see that if you take a polygon, let's start with like a pentagon, right? So 3, 4, 5, okay? If you take those sides and extend them, I'm gonna extend all my sides here, okay? And I take one angle, one exterior angle, okay, from each vertex. So let's say this angle 1 here, then 2, 3, 4, and 5. Remember, we talked about exterior angles. And I take just these exterior angles. So here's angle 1, here would be angle 2, here's 3, 4, and 5. Okay, and I put them together, just the exterior angles, I end up seeing a circle being formed. Okay, so that gives us our second theorem, which states that theorem 11.2 is our exterior angles theorem, okay? And it says that the sum of the exterior angles of a convex polygon, any polygon, is 360 degrees always. Okay, it doesn't matter if it's a triangle, quadrilateral, pentagon, doesn't matter if the polygon has 20 sides. If you take one exterior angle from each vertex, they will always add up to 360. So then our corollary to that, or addition to that, okay, says if it's a regular n-gon, n just being the number of sides, then the measure of each exterior angle is going to be 1 over n times 360. Just like the corollary to 11.1. You take the sum and divide by how many sides. So the corollaries just work for your regular polygons, okay? To find the sum of each one, it is just total divided by how many there are when they're all equal. Okay, so those are our theorems from 11.1. Now we can look at some of the examples, okay? So I have this polygon. And this angle is x degrees, this is 114 degrees, 105 degrees, 102 degrees, and 135 degrees. We are looking to find, I know the numbers are sometimes hard to read, that's why you guys have the printed out notes too, okay? We want to find the value of x. So we have to start by finding the sum, okay? And the sum of the angles is the number of sides minus 2 times 180. Okay, well, how many sides does this polygon have? There's 1, 2, 3, 4, 5. Okay, so the sum of the angles is 5 minus 2 times 180, which is 3 times 180. So the sum of the angle measures in that polygon is 540, okay? Well, the sum just means you take all the angles and add them up. So x plus 114 plus 105 plus 102 plus 135 has to equal 540 because that's the sum, because we know it has 5 sides, and these are all of our angles. So then now it's an equation that we can solve. So if we add up all these numbers, we get x plus 456 equals 540. Then get x by itself, you're going to subtract 456, and you get that x is 84 degrees. Okay, so you start with the sum and then work from there once you know what the sum should be. Okay, we know that the measure of each interior angle of a regular polygon is 165 degrees. Okay, we want to know how many sides there are. Okay, well, the corollary told us that the interior angle of a regular polygon is going to be equal to the number of sides minus 2 times 180 divided by the number of sides. Okay, but we know that the angle itself is 165 degrees. So we know that 165 has to equal n minus 2 times 180 divided by n. Okay, so you have to solve for n now. So first thing is get rid of your fraction. So we're going to multiply both sides by n. So 165n equals, then we're going to distribute the 180. So equals 180n minus 360. Okay, then I would subtract 108. I put the n's on this side. So subtract 180n from both sides. You get negative 15n equals negative 360. And then divide by 15. And you get n is 24. So this polygon would have 24 sides if it's regular and an interior angle is 165 degrees. Okay? All right, so that's the interior angles. Exterior, always add up to 180 or add up to 360 no matter how big. Okay? So I have this figure. This is y degrees, 2y, y, and 2y. We want to find the value of y. Okay, so these end up being exterior angles. So we know that the exterior add up to 360 degrees. Doesn't matter how many sides there are. Okay, so one angle at each vertex tells us that 2y plus y plus 2y plus y has to equal 360 degrees. I just took each exterior angle and added them up. Okay, then I'm going to simplify and find y. So 2y, 3y, 5y, 6y. Okay, I'm just adding it up. So 6y equals 360. Then if you divide by 6, you get y equals 60. Okay, exterior, always add up to 360 no matter how big the polygon is. Okay. Then I have this figure. Okay, and I have one extended side here told this is x degrees. But then if I look at this, okay, the markings tell me something about this polygon. Okay, the markings here tell me this is a regular polygon. Angles are congruent, sides are congruent, okay? So then I know that this is an exterior angle, and I have a theorem that tells me one exterior angle of a regular polygon is 1 over n times 360, where n is the number of sides. Okay, so all I need to do is how many sides are there? Well, there are 6 sides, so n is 6. So the exterior angle is 1 over 6 times 360, which happens to also be 60. So each exterior angle on this polygon is 60 degrees. Okay, so the sum is always the number of sides minus 2 times 180, and the exterior angles always add up to 360, no matter how big your polygon is.